This is activity 4, think before you step. And this is the cool down for lesson 6, strategic solving. So think before you step. You go through steps to solve equations, and they're just reminding you to think about what's going on before you go to the next step in solving that equation. So without solving, identify whether this equation has a solution that is positive, negative, or 0. So without solving this, what can you think about that tells you that x is either positive, negative, or 0? Well, you have to go through a few ideas. You have to make some moves, and one move I can make is I'm going to change this to addition, to adding a -5. And so now if I get rid of that -5 by adding a +5, the idea here is to realize that this side becomes positive. You're going to have more positives over here than negatives. And so you're going to add +5 to make this 0, add +5 over here. +5 plus -3 is a +2 actually. So you're going to end up with +2 over here. I'll show you that in a second. But then we can remember that from earlier that a positive number of positives is a positive. So if I have a positive value over here and I'm multiplying by a positive factor, a positive number of positives, that means that x has to be positive because I'm going to have a positive number of those x's. And it's going to give me a positive answer, which is +2. So x has to be positive, and x actually equals, so if 3x equals a +2, so now we've answered the question, but let's figure out what x is. If 3x is equal to +2, then x is equal to 2/3, because it's 1/3 of this 3x, and it's 1/3 of 2. So 1/3 of 2 is 2/3, 2 times 1/3. Now a visual way to look at that answer is to start out with 3. So this is 3 positive squares here. And if I take 2/3 of those 3 squares, that gives me 2 squares. So these 2 squares are 2/3 of these 3 squares. And then if I add a -5 to that, these 2 squares, you're adding the additive inverse, so these 2 squares become 0, and you're left with -3. So this is just a visual picture of solving this equation up here. Start out with 3, take 2/3 of 3, that's 2, and then add -5 to that. It's really proving that x is equal to 2/3. So going through those steps. All right, so in this equation, what are you going to think about before you solve it? What are some strategic steps to take? Well, this equation is pretty tricky, actually. There's a lot of subtraction, distributing what do you call that? You don't distribute subtraction, you distribute a +1 in this case. You're subtracting a +1 times this amount in this group. So I'm going to go through, and the first strategic move I'm going to make almost every single time is to change subtraction to addition. So if you do that, for me to do that, it makes things a lot easier for me to keep track of what the signs of all the terms are, and then I can move things around because everything's addition. So this is adding a -5, adding a -1. This is subtracting a +1. So I'm just reminding myself, actually, that this is a +1 here and adding -3. So if I go back, look at each of those changes and make sure they make sense to you. This is the inverse operation and adding the additive inverse. So the inverse operation and the additive inverse. Inverse operation, additive inverse. Inverse operation, additive inverse. And then this is the inverse operation, so change this to adding a -1. So inverse operation and the additive inverse of a +1 is -1. So now I can distribute, and it's easier for me to keep track of the signs. So -5 times x is a -5x. So you can read this as the opposite of 5x. The opposite of 5x is a -5x. The opposite of 5 times negative 1 is, this is negative 5. The opposite of negative 5 is positive 5. Over here, the opposite of 2x is a negative 2x, and the opposite of a negative 3 is a positive 3. So everything now is addition. So I can move things around, I can combine like terms, and I don't have to worry about any subtraction. So if I do that, I end up with a negative 4x here. Negative 5 plus 1 is negative 4, and I end up with a negative 1x here. So this is a negative 1x plus positive 3. Now I notice that if I add a positive 4x to get rid of this negative 4x, that's going to make this side positive x's because I'm going to have more positives than negatives. So I want to move in that direction. I want the x's to be positive. So I'm going to add a positive 4x to get rid of this and add a positive 4x here. And that means I'm going to have to get rid of this positive 3. Well, to do that, I'm going to add a negative 3. So add a negative 3 here and add a negative 3 over here. So that's what I did here. I added a positive 4x to get that positive 4x over here, and to get rid of this negative 4x, and I added a negative 3 to get rid of this positive 3, and I end up with negative 3 on this side. So now I can combine these terms. This becomes a positive 2 equals a positive 3x. So positive 2 equals a positive 3x. And now if I have 3x's, I want to figure out what 1/3 of that is. So if I have 3 things, what's 1/3 of that? So that's 1/3 times 3x. And I also have to look at 1/3 of this side because these two sides are equal. So if I'm going to look at 1/3 of 3x, I have to look at 1/3 of 2. So 1/3 of 2 is 2/3. And this side, of course, is x. So x equals 2/3. X equals 2/3. So now you can take this 2/3 and replace each of the x's up here and see if, in fact, 2/3 is a solution to that equation. So take the 2/3 and replace each of the x's with 2/3. Let's zoom in on this. And so now I'm not going to change this to adding a negative value or adding a negative 1. I'm just going to work through, because I can do the calculations within the parentheses. But it still takes some effort because this is kind of odd here, 2/3 minus 1. So you have to kind of remember that that 1 is actually the same as 3/3. So now you have 2/3 minus 3/3. It might be easier to make that change so that it's the same as adding a negative 3/3. So now you have a negative 3/3 plus 2/3 is a negative 1/3. Might be easier for you to think of it that way. It's easier for me to think of it that way. So now if I have 5 of these negative 1/3, I have a negative 5/3. So now I'm going to subtract that. So to subtract a negative 5/3, you learned, and it's probably the most straightforward way to do this, is to use the inverse operation and to add the additive inverse. So this is adding a positive 5/3. Inverse operation and additive inverse. Add a positive 5/3. So now we're down here to 2/3 plus a positive 5/3. Actually, we're going to see that that's the same over here. I stopped here. I could have added the 2 plus 5 and got an answer of 7/3. But we really don't need to do that. All right, over here, 2/3 minus, and this is 2 times 2/3 is 4/3 minus 3. Well, easy way to calculate that is to remember that that 3 is 9/3. So we multiply by 3/3, that gives you 9/3. Change the 3 to thirds. And so now 4/3 minus 9/3. That's the same as adding a negative 9/3. Negative 9 plus 4 is a negative 5. So you end up with a negative 5/3. This is the same, written in the same way on the right side as right here. So I could have stopped there if I wanted to. But you go one step further. Again, inverse operation, because I want to add rather than subtract. So I'm going to use the inverse operation. That means I have to use the additive inverse of this term here. So the additive inverse of a negative 5/3 is a positive 5/3, and that gets me down to the same thing over here. And again, I could have added the 2/3 plus 5/3 and gotten 7/3. So I would get 7/3 equals 7/3. Tricky little problem.